Yes, yes.
Sir, good morning. I am also
Good morning,
online.
Sudhir. You have reached there. Good.
Yeah, I've reached here. Yeah, I've just reached actually. So I'm joining using my mobile. So I won't be able to show my face, sir.
Okay. Okay. Anyway, we can have the voice.
Yeah,
Yes.
yeah, yeah.
So nice of you, sir. So we will wait for Professor Gunte also, who is the main lecturer, who is going to give lecture. So once he joined, we can start. Datan sir, we will wait for 5-6
No
minutes.
problem. No problem. I am available here. Yeah.
Okay, sir. Yeah. Good morning, Professor Sachin.
Good morning, sir. Good morning. How are you?
Yeah, fine, sir. So we will wait for just
My telephone connection, so there won't be any disturbance to you.
yeah. Yes. So yeah, Professor Sudhir and Dr. Dattan Saab all has joined, but we will wait for 5 more minutes. Some more people are,
Sure,
keep
sir.
on joining.
Sachin, good morning.
Good morning, Professor. Good morning.
Sa- yeah.
Yeah. Yeah, Professor Gunte Saab, you can just, that share and see that PPT. So hope that
So my voice is clear, sir. There is no problem with the voice.
no, it's okay. Fine, fine,
No, your voice is fine, fine. Yeah.
fine.
Okay, so it is asking me to. Okay, I have to go to the system preferences and do something to allow it. So give me a second.
Yeah,
It is asking me allow the record to your contents folder. I have to log out and then do it again. Just give me a second.
yeah, yes. So we are actually broadcasting this through YouTube also. So some people may directly join in YouTube. Yes, sir.
Can you see my screen as a full screen?
Yeah, yes, sir. No, you can,
It's in the normal mode,
normal
Sachin.
mode. You have to protect.
Oh, it's still not in the presentation mode?
No,
No.
no.
Okay.
But it is readable. Yeah.
Yeah, it's very small. When you share maybe full screen, you can first PPT can be open and then use.
Yes, now it is.
Okay.
Yes, yes. Okay. I think, sir, Ratan sir and Sudhir sir. So I think we have, good number of people have joined.
Yeah, we can start.
We can start. Ratan sir,
Yeah.
shall we start then?
Yeah, please go ahead. Please go ahead.
Yeah. Yeah, Shilpa, you are there?
Yes, sir.
Yeah, so you can start. Okay.
Okay. Good morning, everyone. We all have gathered here for the ICCS online lecture series on climate change, and today is the inauguration of this lecture series, which will run every month. Today's lecture will be presented by Dr. Sachinis Gundhe on aerosols and climate change. We all know that climate change is one of the most severe concerns we have today. Since we have time limit, I don't want to elaborate the topic. So now we will move on to the inaugural session. You can also watch this session live on YouTube by streaming into the official YouTube channel of ICCS. I also request all of you other than speakers to kindly turn off your audio and video. Now, I would like to invite Dr. Shivananda Pai, Director of ICCS, to greet all of our distinguished guests and participants. Please, sir.
Thank you, Shilpa. Respected Dr. MC Dattan sir, Padma Shri MC Dattan sir, Executive Vice President Professor Sudhir sir, who is chairing this session, and our main lecture, today's lecture, Professor Sachin Gunte, and all my friends and colleagues from IMD and ICCS and other institute who has joined here for this online series inauguration, first lecture from ICCS lecture series on climate change. Good morning, namaskaram. Welcome to you all. So before officially I welcome each of these our main guests, I will just brief you about few sentences about ICCS. As you know, ICCS is an autonomous scientific body under Kerala State Council for Science, Technology and Environment, and its vision is to empower the state of Kerala for the inevitable global consequences of climate change and enhance the resilience and adaptation of the state through science, technology, and self-awareness. Towards this, ICCS is acting like a climate change knowledge center where we are collecting all the data related to climate change in respect of the state and its impact on various climate sectors like water, health, transport, energy, tourism, etc. And actually, we are also working, analyzing this data and bringing out various aspects of observed climate change in the state and also projected climate change in the future. And also, we are also consulting with the various user sectors to identify what are the climate services they require. At the same time, we also monitoring what is happening in the state. And in this respect, you may be remembering last month we had our Chief Minister, Honorable Chief Minister, had released the first climate statement for the state level, which is the first in the country itself. We had released the statement for the last year, 2021, in respect of the state. And now, in order to bring increase the awareness about the climate and also to bring out what is the latest research in the field as far as the state as well as the country and even global level research to the public and the scientists, we are also conducting a lecture series on climate statement, and this lecture is the first in the series. And Professor Sachin S. Gunte, he, in spite of his lot of assignment in and work in national and international level, he agreed to give us this lecture, to deliver this lecture. I welcome him for this lecture series. And we have Professor Padma Shri MC Dattan sir, who is actually inspiring us actually to do more work since I came in February. He has been behind guiding us how to take up ICCS much better way. So I welcome him also in this online series to inaugurate that. And then also we have got Executive Vice President of KCST, Professor Sudhir. I welcome him to this online inauguration function of the online lecture series. I also welcome all those who are attending this online lecture series. All the scientists from IMD and all other our sister organization, and from various colleges, media, etc. With this, I stop here. Back to Shilpa for the next. Shilpa.
Thank you, sir. Professor K.P. Sudhir, Executive Vice President of KCST and ex officio Principal Secretary, Department of Science and Technology, Kerala Government, is a persistent supporter of ICCS in achieving its aims as a climate change research institute. Since 2003, he has been a faculty member at IIT Madras Civil Engineering Department. His main research interests include hydrologic modeling, stochastic hydrology, hydrological forecasting, predictions in ungauged basins, uncertainty analysis, application of ANN and fuzzy systems in hydrology and water resources, etc. I would like to invite Sudhir sir to deliver his presidential remarks on this lecture. Please, sir.
Thank you, Shilpa. Am I audible?
Yes, sir, you are audible.
Yes, sir. Yes, sir.
Respected Sri Chandradattan sir, my friend and colleague Sachin, Dr. Shivananda Pai, the director of ICCS, other dignitaries assembled here. It's indeed a very good moment to know that the Institute for Climate Change Studies is organizing a series of lectures in connection with the climate change and associated factors. In fact, though the institute was started in 2014 in the Kerala state, the activities pertaining to the real focus on climate change was a little less there. And in the year 2020, this institute was brought under the ambit of Science and Technology Department from the Environment Department, and specifically at the ambit of Kerala State Council for Science, Technology and Environment. After that, there were a lot of activities happening in the ICCS, and we brought Dr. Shivananda Pai as the director of the institute, an eminent scholar and a scientist who is a scientist at India Meteorological Department. I'm pretty sure that anybody who works on climate change related activities, especially the precipitation, would certainly remember or would have read the paper Pai et al. And then Dr. Pai is the author of that article, one of the authors of that article. So essentially, when he took over as the director of ICCS, he has planned several activities for the institute in helping the state government to develop policy level activities related to climate change and its mitigation. And in that context, he had planned for one of the lecture series, and he also has plans for developing a network of rain gauges, which is currently a problem in the Kerala state. And and then the advantage we have is, since he belongs to the IMD community, he has a good contact with IMD and he is able to establish all those things. So as a first step, ICCS has started establishing automatic rain gauges in all of the research and development institutes under the KSCSTE. In addition, he is actively involved in giving inputs to various sectors of the Kerala state government in giving either the warning or developing policy matters related to climate change. Specifically, Kerala has experienced uh, last 5 years, if you look at, we have been experiencing natural disasters pertaining to extremely heavy rainfall and cyclones, and that is where the state government has to come up with different policy decisions how to mitigate the negative impact of all these natural disasters. It is in this context, in 2019, Kerala government has constituted a committee to look into the possible causes and develop policy responses in connection with the repeated rainfall extremes and the landslides that have happened in the state. Professor Sachin Gunte was one of the committee members, and the report of the committee enlightened there were a specific role of the aerosols in the extreme heavy precipitation which has happened in 2018 and 19. And Sachin was very dynamic in establishing a monitoring laboratory at the College of Engineering, Munnar, from IIT Madras and in collaboration with ICCS. And they are continually monitoring the aerosol concentration at the level, in addition to several other atmospheric science parameters. So, IIT Madras, specifically Sachin and ICCS, has a close collaboration, and we are coming up with several intuitive results, which is evidenced by the measurements made by this laboratory. And we plan to establish a long-term collaboration and extend the collaboration to several other aspects of learning climate change impacts in the state. So I would like to thank Sachin as well as Professor Pai for the venture which we are doing. And also would like to appreciate the efforts put in by the director of ICCS and the team to develop this series, which will be much beneficial for the community in Kerala and elsewhere to understand about the various aspects of climate change. Mostly, we know that climate change happens through changed precipitation pattern and the temperature pattern, but the root cause of it is not, unless you are really interested in reading those articles and papers, you wouldn't come to know what exactly is making the real changes in the climatic pattern. In fact, a couple of my colleagues at ICCS has been working on understanding what actually is happening during the climate change. We have also planned several research programs with the help of DST funding in these lines, and the results will be disseminated very soon. And there are interesting results which is coming out. And in that context, this kind of lecture series would be very much beneficial for the community who is attending this. And I would like to appreciate the team for developing this. And I should also mention that the Kerala government has been supporting the Institute for Climate Change Studies, and the government want the institute to come out with several policy decisions or policy implications and advices that can be implemented on field. And I would like to mention Padma Shri Chandradattan's role here. He has been constantly encouraging the KSCST in general and the ICCS in particular, because he feels that there are a lot of opportunities and scopes to be explored by the ICCS in this area. And he helps us in establishing connections with various other sectoral importance and the institutes. And I'm pretty sure that with these initiatives, ICCS will grow further into higher heights. I don't want to lengthen my introductory remarks. With once again congratulating the team of ICCS and thanking Professor Sachin Gunte and Padma Shri Chandradattan, I would like to end my talk here. Thank you very much for this opportunity and all the best.
Thank you, sir, for your constant support and encouragement. Now, our chief guest is Padma Shri M.C. Dattan, scientific advisor to the Honorable Chief Minister of Kerala. He is an Indian space scientist and former director of the Vikram Sarabhai Space Center. He started his career in 1972 by joining the Indian Space Research Organization, where he worked for the SLV-3 project, the development of solid propellant formulations. He also contributed to the realization of solid motors for SLV-3, ASLV, and PSLV project and became the director of the Satish Dhawan Space Center in 2008, the director of the Liquid Propulsion System Center in 2013, and in 2014 he was made the director of Vikram Sarabhai Space Center. He was also the head of the Launch Authorization Board of Chandrayaan 1 project. Sri Chandradattan is a recipient of many honors and awards, including Performance Excellence Award from ISRO, Outstanding Chemical Engineer Award from the Institute of Engineers, and Individual Service Award from ISRO. The Government of India honored him in 2014 by awarding him the Padma Shri, the fourth highest civilian award for his contribution to the fields of science and technology. I humbly request Dattan sir to provide the opening remark for this program.
Thank you. Thank you, everybody. Good morning to all the distinguished audience attending this lecture series. First of all, let me thank Dr. Shivananda Pai for organizing such a lecture series in the field of climate change, because the subject has become very prominent nowadays. In fact, as Dr. Sudhir has very rightly pointed out, the Institute for Climate Change Studies under the Kerala Government Science and Technology Council, though it has been formed about almost 6 years back, the activities were not worth mentioning anything. It was a very unfortunate thing, and though I have taken an initiative with the advice of Chief Minister to transfer this Institute to Science and Technology Council, because there is a reason for that. We have about more than 7 institutes already, in which, the institutes dealing with forestry, institute dealing with, that is in KFRI in Pichi, and the Water Resource Development and Management Institute at Calicut, and the Transport Operation Planning Institute in NATPAC. All these 3 institutes are connected to one way or other way with the climate change and climate prediction. So it is, I found it is very apt for, adding to the council, a part of this Institute for Climate Change Studies, but with the CM's consent and support, we could do it. But in spite of that, the Institute could not get a leader for leading the team and making activities. A few months back only, we were so fortunate to get a reputed scientist in this field having very good experience and holding positions in IMD. We could get the service of Dr. Shivananda Pai on deputation to this institute for leading it. He has already, the day he joined onwards, he has started the program under the guidance of Dr. Sudhir, who is also an expert in the water management and engineering, agricultural engineering fields. So I am extremely happy that this lecture series is taking place for creating an awareness among the audience about the importance of the subjects and what we can do, each individual can do to face the situation and to alert the situation and reduce the global warming and subsequently to the climate change drastic effects. In fact, the global warming and climate change activities, if you see any journal or any paper, etc., every day there will be something about it. Very alarmingly, it is coming. It is mainly because the technological development. In fact, yesterday was the National Technology Day. I was really worried, the technology, the way by which it is growing, especially for the last 70, 75 years, globally and also in India after the independence. the number of factories, number of heavy industries, number of thermal power stations which has flourished in our country, it has come is very large, which all resulting for the greenhouse gas emission to the atmosphere to a very, very large extent, which is one of the main reasons for the global warming leading to the climate change. This aspect, I think people should keep it in mind. In fact, when everywhere for the last 10-15 years about the atmospheric pollutions, greenhouse gases, carbon stock, all these things, when people are talking, we, the Kerala people, were thinking that nothing will happen to us because we are a small land, we have a reasonably good amount of forest and about 600 kilometers long seashore, a portion of the Western Ghats. It's a very peculiar type of land we have it. We have about 600 kilometer long sea shore. From there, it just goes to the Western Ghats, sloping very fast. Within a width of about 50 to 70 kilometers, the height goes to 300 meters almost. This concept, we were happy with a moderate climate without much disturbance, getting reasonably good rain. But in 2008, heavy rain and the flood mishap, repeating again within another 2 years in 2020, made the people to be very, very alert and the government has taken initiative to see how this can be addressed. And as you know, the climate change aspect is a global phenomena. If Kerala or India alone tries to do something, it may not click anything like, but still, the awareness will lead to a lot of information scientifically, as we are going to get one of the best talk in the effect of aerosol in the precipitation of the rain clouds. In fact, Dr. Sudhir's committee has made a thorough study about the 2018 flood, the reasons for it, how it happened, why after about 95 to 100 years, a similar flood has happened only in 1924. 1924 only this has happened, and after this, all of a sudden, how this happened? What are the root causes? They have analyzed it and it has come. The main reason is the precipitation. See, we have the rain clouds. We can characterize the rain clouds with the equipment like Doppler weather radars, etc. The amount of moisture content in the clouds and its temperature, the surrounding nature, surrounding temperature, and when the moment it starts condensation or precipitation, how fast the condensation takes place, and what are the parameters which accelerate the condensation. Actually, what happened in our flood 2018 was the quantum of rain, it is called the rate of pouring. The rate of pouring was extremely severe beyond all our expectations, so that the water content which has come to the ground was much, much higher than whatever the water bodies, rivers, canals, dams, etc. can hold. And also because of the style of living and the lack of maintaining the municipal cleaning, corporation cleaning, and etc., the canals, sewage lines, etc. also got blocked. Not only that, the river mouths, which is joining the sea for discharging the water during every rain, there was clogging and shrinking of throttling of the river mouth also. And the Sudhir's and team's reports, they have brought out all these kind of things. Being all these things, etc., scientists started looking into each and every fine parameters which are all causing for this kind of phenomena. Aerosol also is one of such phenomena. By finding the type of aerosol, the particulate matters, the size, its dispersion, and from where the aerosols, that impurities comes, which act as a nuclei for the precipitation in the rain clouds. Even if we find it, etc., we may not be able to do a remedial action immediately, because the aerosol can come from anywhere. It is a kind of things which is related to the industry exhaust, and also maybe from the pollen, maybe from the forestry, or maybe from various places because of our living style. But if we know it a bit early, that the rain clouds which are getting accumulated above our Western Ghats area, if that particular cloud is likely to burst into a kind of heavy rain like what we experienced. We can be alert with about at least 8 hours alert. We are getting it. We can do a lot of things so that the severity of the disaster can be reduced. That is what we can do it. Now, I will conclude my talking telling that for the climate change, global warming, etc., every individual, let us ask a question to us, what can I do? There is no point in telling that should be reduced, this should be reduced. See, we in Kerala, we are so lucky that we don't have any heavy industries much. The exhaust or pollution or emission towards the things are much less. And no thermal power stations, a single thermal power station which was there, that is shut down and it is not working. But we are also responsible in such a way that we purchase electricity from other states who produce electricity by thermal power stations. So while we are using that energy for our comforts levels and luxuries and making use of the energy for that, we are also equally responsible. Second point is the emission through the transport vehicles by burning the fossil fuel. I mean, people have started, government has insisted for the alternate fuel using and etc. Non-conventional fuel using has come up. It will take some more time to gear up. But ultimately, we should find it out why during the last 70 or 80 years time, how it has increased, because science and technology output has increased our luxury. Day by day, new equipments, new luxury equipments, it may be a home appliance or it may be a air conditioner, a vehicle air conditioner, whatever it is, we are adding and adding by consuming more and more electricity or energy. So this addition, why we should ask, why so much luxury? Why so many vehicles? By affording and enjoying super luxuries and becoming addicted to the luxuries like that, are we thinking that the consequences which is going to happen for the coming generation in the global status, in our planet? As rightly pointed out, the nature as such is, the life system in our planet is knitted by a web of various factors like the earth, the water, the air, the forestry, the plants, and the ecosystems available surrounding us. If we are going with our lifestyles, if we go like this, any of that component and a system is going to be damaged or broken, that ecosystem which is the nature has made will go seriously damaged to, which cannot be reconstructed again, which cannot be regained again. That is what now the system going. So I expect the coming, including the next lecture by Professor Sachin, the forthcoming lectures also, Dr. Pai will select a proper way in such a way that the listeners will be educated and they will be mentally made aware about the disaster we are going to face by enjoying the super luxuries and getting addicted to the luxuries day by day. By listening to the series of lectures, I sincerely wish that the people should change their habit of more and more, they should change it to less and less. I mean, from more and more luxuries to less and less luxuries, if you are able to live and change our lifestyle accordingly, this planet will be available for us for comfortable stay for few more 100 years, so that the next generation will not be destroyed or troubled. With these few words, I formally inaugurate the lecture series and wish Dr. Pai and the team to make an excellent awareness to the people who are listening to, or of course all people, it is in the YouTube, many people are listening to it, and let them have a transformation. The people who are listening, let them have a transformation in their approach and lifestyle, and be an eco-friendly life. Let them lead. With these few words, I inaugurate the lecture series, and thanks all the organizers who are responsible for this. Thank you.
Thank you, sir.
Thank you, sir, for your support to continue this program. It's now time to begin our first lecture. Dr. Sachinas Gundhe, Professor of Environmental and Water Resources Engineering at IIT Madras, will deliver the lecture. In 2006, he received his PhD in Physics from IITM Pune with a focus in atmospheric physics and chemistry, as well as his MS from the University of Pune in 2001. He began his career as a postdoctoral researcher at the Max Planck Institute for Chemistry in Mainz, Germany, in the biochemistry department. He began his teaching career at IIT Madras in 2011. His primary research interests include aerosol biosphere climate interaction, aerosol hygroscopicity and CCN activation, aerosol chemistry and visibility over India, aerosol monsoon interaction, bioaerosol variety and ecosystem health impact over India, and atmospheric chemistry climate modeling. He has written 53 papers and participated in 20 research projects. I kindly request Sachin sir to deliver the lecture on aerosols and climate change. Please, sir.
Thank you very much for having me here. First of all, I would like to thank organizers, particularly Dr. Pai and then Professor Sudhir, the Executive Vice President of KSCSTE, for providing me this opportunity. And I think one of the important thing I would now, in the context of my talk, would like to thank Chandran sir, because he had set the premise very right. Like, you know, that he really emphasized that the 9 components which are important for the extreme precipitation, and then how the aerosol is important. And then I'm very glad to have you, sir, because when I was doing my fundamental physics, I was really big fan of the work which you have done on the thrust oscillation for the rocket motors for the ground testing. That was really my area of interest at some point of time in life. But then I'm not by choice, but by default or by accident, I'm a climate scientist. But I still remain a big fan of your work, sir. So thank you very much. Thank you, everybody. And then with this premise, I would like to start this. So if I would like to start this very nice and interesting picture which I have obtained from the NASA observatory. And then you see that this dust storm, like, you know, how it is heading towards the Gujarat region, right? And now one of the very important thing which you would notice from this is that these aerosol or the dust which we are seeing it here, when it is on the ground, it is not really giving you that contrast. But when it is on the water, you can really see that there is a strong contrast. Right? You know, it really gives you more reflection. And this is one of the very basic or the fascinating way that how our aerosols, they affect the climate. And then with this picture, what I'm going to do for next 45 minutes or so is that this is an outline which I will try to follow. So I will try to go through the introduction and motivation. Why aerosols, what are aerosols in the atmosphere, their applications and interaction, how aerosols affect climate, direct and indirect effect. And I'll also give the viewers, just for the orientation purpose, so that I can strike this balance between the experts and then the non-experts, that an orientation about the basic aerosol properties. Then I try to tell that why these aerosols are important from the cloud formation. And Chandran sir has already said this premise, so I would directly go and then say that how they are important. Then I would also introduce the audience to the concept of atmospheric bioaerosol, that how they are challenging. And since I'll talk about the atmospheric aerosols, particularly in terms of the health impact and how this health, climate change and aerosols, they are kind of interlinked. And then we'll try to present you to conclude with the summary and outlook, what are the achievements and challenges we have. I would like to start with this slide that I dedicate, like what I have is to Professor Paul Crutzen, who got this Nobel Prize in 1995 for the discovering the ozone hole. Right? You know, had it not been Paul Crutzen and his colleagues in 1995, majority of us would have been started suffering from the skin cancer. Right? So why the fundamental research is important, it tells you. And then Professor Paul Crutzen has introduced this term called scene. Anthropocene geological epoch. Like, if you look onto this particular epoch, right, starting from 4,500 million years ago, and right now we are here. And then what essentially the Anthropocene means, that it is an era where it is more, the Earth system science in general is more governed by the human activities than the natural activities, right? If you go back 400 years back, most of the Earth system science in general was governed by the natural activity. But just to give you an example, look at this increase into the CO2, look at this increase into methane, and then of course in the particulate matters over the just period of 400 years, right? So we are now living in an Anthropocene era, and then the credit goes to Professor Paul Crutzen, and then it's unfortunate that we lost him last year, and then this is all dedicated to Professor Paul Crutzen. Coming to the aerosols are nothing but the fine suspended particles in the atmosphere, and they range it from the diameter or the size starting from 1 nanometer to 100 micron. So let's try to have this thing clear here in our mind, that when you talk about the aerosol research, it is extremely difficult and then slightly more complicated as you talk about the greenhouse or any sort of a gas research. Because with the gases, you don't have to really deal with the 5 to 6 order of magnitude size range, which we have to deal here, right? And then on top of that, the gas concentration, once you fix on ozone, you fix it on ozone. But we do have a different type of aerosols, right? We have sulfate, SOA, soot, mineral dust, and then in terms of biological, like the proteins, viruses, bacteria, so on and so forth. And anything above like generally 100 micron, we don't call it as an aerosol because they very quickly settle on the Earth's surface, and then they are not really suspended in the atmosphere for long. Now, when you talk about the aerosol sources, they have both natural, like the volcanic eruption, sea salt, as well as the anthropogenic sources, like what you burn, drive vehicle, aircraft, everything. What you do is the anthropogenic sources. Within those sources, they have primary or the secondary, like they can directly emit it primarily from the biosphere or human activities, or they can also be formed secondarily by the gas to particle conversion. However, once they are into the atmosphere, they can undergo the transformation, which we call it as a chemical and physical aging, means that they do change their properties. But the most important aspect is that they play an important role in the cloud formation, like they are responsible for the cloud formation. Now, depending upon the one which they play a role in the cloud formation, they are removed by the wet deposition. The one those who do not take the part into the cloud formation are removed by the dry deposition, and this is how they basically complete the cycle in the atmosphere. Now, just to summarize that, the key message from this slide is that the aerosols are complicated to study. They do affect the atmosphere and climate, as I will kind of unravel that as I progress with my talk, and then they do also impact the biosphere and human health, particularly in the context of the biological aerosol, which I will try to touch upon as I progress. Now, let's try to understand the basic effect of aerosols. Like, we talk about the direct and indirect effect. I would just give an oversimplified version of this effect. If anybody has a question, we can try to discuss at the end of the talk. So direct effect is that you have these aerosol particles in the atmosphere, you have the incoming solar radiation, and then depending upon these properties of the aerosols, like whether they are black or white, they would either reflect more sunlight if they are white by cooling the Earth's surface. If they are black in the nature, they will absorb it as a typical black body radiation and then emit it at all the wavelengths by re-emitting and then warming the Earth's atmosphere at large. So that's a direct effect. You have a semi-indirect effect that when you have the aerosols, they go into the clouds, they can perturb the cloud properties. Either cloud can be white or black, depending upon the aerosol properties, and that's a semi-indirect effect. Then we have this cloud albedo effect, which is again linked to that. Like if the white cloud is there, obviously it will reflect more back into the space by cooling the Earth's surface. But then the lifetime of the cloud is also important, right? You know that how long that is going to reflect and then what is the cloud base. So not necessarily that the clouds will always cool the Earth's surface, but depending upon the depth and base, cloud base, it will also try to warm the Earth's surface, as I will tell you. So this is just the glimpse of what is the direct and what is the indirect effect. Along with the greenhouse gases, as we know that the greenhouse gas basically tend to warm the Earth's surface, but what we basically know as of now, the aerosols, they tend to cool the Earth's surface, right? But there are slight complications in that, and then there are large uncertainties in that. Like you have the aerosols are important for the cloud and precipitation. Then we do have an aerosol feedback on the moisture and winds and temperature profile, how the regional variability goes in. And all that stuff which is related with the aerosol, of course, to the different feedback, then goes on to add the effect on the radiation again. And then once you have this radiation, meaning that incoming solar radiation, that how they are affecting how the earth is warming, then that basically goes on to define the global surface temperature, which can again have an impact on the radiation, because you have more water vapor, which is one of the strongest greenhouse gas, and then it can increase the earth's surface temperature. So this is all just to give you that what are the complications and where do the aerosol stands with that. Now, just to simplify the previous slide and then to give you the context that why at least I am more concerned with the aerosol, is that this is a very familiar figure for the climate scientists. And this is a very simple thing to understand, that what it tells you is that on the right hand side, these are the constituents which are basically takes to warm the earth's surface, like carbon dioxide, methane, nitrous oxide. These are the greenhouse gases which are warming the earth's surface. But then you have the aerosol effect, that the aerosol radiation interaction, like how do aerosol interact with incoming solar radiation and aerosol cloud interaction, they tend to cool the earth's surface. But here is the point. The point is that if you look into the error bars which are associated with these estimates, that how much the gases are warming the earth's surface, but if you look, they are very small. It means that we fairly have a pretty good idea that if you emit 1 kg of CO2, how much it is going to warm. But if you look into the estimates associated with the aerosol effect, particularly the aerosol cloud interaction, those estimates are bigger, those error bars are the bigger than the estimates, right? And then IPCC themselves say that they have the low confidence in their estimates when it comes to the aerosol cloud interaction. So what it means that when you try to calculate the net estimate of the radiative forcing, or the net estimates that how much the Earth's surface is going to warm by the end of this century, the aerosol cloud precipitation interaction represents the largest uncertainty in the current and in the future understanding of the climate change. For example, that IPCC for last 35 years saying that like the Earth's temperature would increase by 1.5 to 4.5 degrees centigrade by the end of this century, but we don't have a fixed number. Please keep that in mind. Now, how do we basically solve this problem? Well, unfortunately or fortunately, only my group or only IIT Madras cannot solve this problem. And that is the reason the climate science, particularly related with the aerosol cloud precipitation interaction, needs a very large-scale collaboration, which includes laboratory experiment, field measurement campaigns. This is where we, particularly at IIT Madras, focus. And then you have the representative laboratory experiments. Then this data can be upscaled, can be measured at the contrasting environment at distinct season over India. It can be upscaled to the cloud property and process models, then to the regional atmospheric models, then to the global atmospheric model, and then to the global climate model, so that you can get the net estimates that how much the Earth's surface is going to warm in that. Now, since we talked about the cloud, let me give you this idea that how do the clouds basically spoil the complete understanding. Now, generally we try to calculate the Earth's temperature increase from the 1750, that year 1750, that how much it has increased. Why 1750? Well, that's a year basically when the human have started burning the coal to remove the water from the coal mines to get more coal, right? So that's the area when we started really messing up with the atmosphere. Now, if I look into the greenhouse gas concentration, even if I go like 100,000 years, I fairly have an idea that what that greenhouse concentration was. How do I know that? Well, I go to Antarctic, I drill the ice cores, I pull that ice core, look into the bubble which is trapped in there, do the carbon dating, and then I know what was the concentration. If I know the concentration, I know how much it is warming. I just use the Arrhenius law and then calculate how much it is going. Now, what happens with the cloud? Problem with the cloud is that depending upon what that cloud base is, or where that cloud is lying in the atmosphere, or how deep that cloud is, the cloud can either warm or cool the Earth's surface. Now, we know that due to the increase or changing aerosol properties due to the human activities, the cloud properties have also changed in the last 300 years. However, what we do not know is that how the clouds were before we started messing up the atmosphere, just like the greenhouse gases. So I have a really uncertainty to kind of deal with. I don't know what the clouds were doing, but what we know as of now is that the clouds overall really kind of cooling the Earth's surface, right? If there are no clouds, obviously the Earth would be warmer by 12 degrees centigrade. But the cloud, if they radiate back to 7 degrees centigrade, then what we agree by now as a climate community that the net effect of the cloud cooling is 5 degrees centigrade as of now. But I do not know, because since I don't have the references back in the history, I do not know how it is going to change in the next 50 years or so, right? So that's how the clouds basically, they not only responsible for the flash flood, landslides, but then they spoil my future understanding about the climate change as well. In addition to that, the cloud formation is important because it when the water evaporates, of course, it absorbs the latent heat of evaporation. Latent heat, then when the cloud is formed, that condenses onto the aerosol particles, so that releases that latent heat into the atmosphere. That's how it really recirculates the energy into the atmosphere. But beyond and above the clouds, of course, the clouds are important for the rainfall. And then why rainfall is important? It's a key link in the hydrological cycle. It's the most direct effect on life quality. If you don't get rainfall, the share market crumbles. Most poorly understood, but yet it's an essential climate variable and plays a key role in climate system. So in a sense that we do owe our existence to the aerosol particles. If the aerosol particles are not there, we'd probably not survive here. Now let's try to understand, since we understood the very basics of this, let's try to understand what do the basic aerosol property means in here. Well, since I know very fundamental physical, chemical, and biological properties of the aerosols, let's try to look into the physical properties. Like one of the very important physical properties of the aerosol is the size distribution. It's very simple to understand. You measure the diameter and plot it on an x-axis, which goes from like 1 nanometer to 10 micron, and then you simply plot the concentration of these aerosol particles in each size range which you are observing. But just for the very fancy representation, what you do is that you simply normalize, take the difference of that concentration and normalize by the log of that diameter width which you are taking it. And then this is what you really get a very nice log normal size distribution. The aerosol community, to basically understand the sources, have divided that into the different modes. Like the first mode is the nucleation mode, like from roughly 1 nanometer to 20 nanometer. Then we have an Aitken mode, like roughly 20 to 100 nanometer. Then we have an accumulation mode, which is mostly like 100 nanometer to 1 micron, and then generally above 1 micron, we call it as the coarse mode particle. Look into the chemical properties. When we look into the chemical properties, if you take a single aerosol particle in atmosphere right outside your window or right outside my window or anybody who is sitting in there, roughly it would contribute like around 50 to 70% of organics. I'll talk about it more. Then the sulfate, which comes from the anthropogenic activity. Then you will have ammonium, which comes from the agricultural and livestock activity. You will have a little bit of nitrate and a little bit of sulfate. But you will also have other components like potassium, iodine, but they are very small in a trace element, right? So this is how the chemistry would go. And going to the organics, for example, it is further divided into the different components and makes it more complicated. When you talk about the biological properties, it's not that the fault of your screen that you don't see it there, but it has been purposely kept it blank because it's very difficult for me to define what do I really talk about the biological properties, because it is more complex. It is a morphology, the species level, like which type of fungal spores, which type of bacteria, which type of viruses. If I talk about the bacteria, like, what are the different bacteria? So there are much more complications associated with it. That is the reason I purposely kept it blank. But as I go on to my talk, I'll try to explain it that what that complication about it is. Now let's try to understand the strong contrast as far as the Indian region is concerned, and then how does it really affect your regional or the local climate. Nothing so special about this, very simple. For all these three figures, on the x-axis you have the diameter as I have showed you, and on the y-axis you have the normalized concentration. Now one of the first difference which you see here, that from left to right in your screen, it is becoming clean to polluted. So if I look into the measurements in Munnar, which were kind of carried out long back, and now we are collaborating with ICCS for this, that the total particle concentration is only 583 particles per cc. When I go to Gadanki, which is a semi-rural site near Tirupati, this particle number concentration goes up to around 3,300 something. But when I go to Delhi, that this total particle number concentration is approximately 25,000 particles per cc. Right? So how you can really see that how these aerosol properties are changing. But not only the numbers, which is very important for me to understand the climate effect, but it also gives me that a basic idea that what could be the source depending upon where the peak is, whether it is broad or whether it is narrow, so on and so forth. So you can see that over the Indian region itself, there is a very strong contrast as far as even a basic physical property like size distribution is concerned. Let's come to the chemistry. It's even more complicated. Now what it shows you on the left hand side, this particular graph shows you that I just picked up some of the data from the literature, and then this pie chart basically show you the green is organic, orange is ammonium, blue is nitrate, red is sulfate, and this magenta is chloride. Now you see that within India that there is a very strong variation. But pay attention to this number which is written after this, right? This represents the total concentration of PM1 per microgram per meter cube. In 1 meter cube, this much microgram you have. Now look at this range it goes in from, right? The highly polluted Kanpur in Indo-Gangetic plain has like 437 microgram per meter cube, all the way down to Munnar, which is only having 7 microgram per meter cube. If you look into the chemical composition, let's try to look into the Delhi, which has organics first, then chloride, which is very surprising. I'll talk about it. Then you have ammonium nitrate and sulfate. You come to Chennai, it is organic, sulfate, ammonium nitrate, chloride, and then you go to Munnar, based on the measurements which we did here in this summer in collaboration with ICCS, you have organic, sulfate, ammonium nitrate, and chloride. But what happens here is that when you move from smoggy capital to the pristine hills, not only that your concentration is reducing, but the chemistry, which is more complicated, is drastically changing. So that's the basic chemistry. Now here is the biological part of it, like why I did not show it to you. Look at this figure. These are just the basidiospores, like the fungal spores which are flying all around in the air. Now these basidiospores are same. The species level is same, whether it is in Chennai and in Munnar. But the typical complication is that although they almost belong maybe to the same species, their morphological characteristics are totally different. Now, whether do they have this kind of a morphological structure because they have to survive in a certain environment, I don't know. But what I do know is that their implication on the climate, or particularly for the rain formation, is going to be extremely different. Look at this, for example, right? And if you look into the size distribution of these bioaerosols now, like for the Munnar monsoon, even for the same location, during different seasons, they show totally different type of size distribution. So that adds another complication. Not only that, I have a complication related coming from Kanpur to Munnar, but within Munnar, depending upon which season I am measuring, I have an additional complication that the aerosol properties would change. Look at this, like, if you look into this is the ratio of bioaerosol to the total aerosol. Of course, I expected that the Amazon would have more bioaerosol particles, but what it shows you that it is more complicated than one would expect as far as the bioaerosol is concerned. Now, once we understood what aerosols, why they are important, how they form the cloud, what are their basic properties, let's try to understand their implication for the local or regional climate change in the Indian perspective. Now, this is a Munnar where we have a beautiful town. We have a very nice lab. Please do visit if anybody wants to visit it. Let us know. What happens in Munnar, that if I look into the wind which is coming at Munnar during July month, it is really a very clean marine influx which is coming from southwest direction. But at the same location, when I stand there in January, my wind is coming from the northeasterly direction, which is really coming with a lot of polluted airs, right? So that's the complication number one. If you look into India as a whole, India has a very diverse land use pattern. It goes from like snow, ice to the urban and build-up land, right? And then in between you have savanna, desert, cropland, evergreen mill forest, snubland, grassland, everything, right? So that's the another complication. And then the third complication which we have that India has a very heterogeneous population distribution. If you look into the Indo-Gangetic plain and then this very small strip of Kerala here, they are very densely populated. So three important contributions: contrasting wind, diverse land use, and then the strong regional population distribution, which also perturbs the source characteristics of the aerosols are different. Now let's try to understand that at a contrasting location, how does it basically affect the regional climate? Now these two contrasting locations, as an example, we have Gadanki, semi-rural, we have Munnar, which is pristine. I talked about the number concentration is very low in Munnar as compared to the Gadanki. You see the wind which is coming at Gadanki is totally different than what you're getting in Munnar. Now what is the implication it has? Let's try to understand this. Let's say you have this initial aerosol particles in the atmosphere, and this is an updraft velocity, meaning that with what velocity your cloud is going up. Higher this velocity, better the chances of cloud formation and better the chances of rain. Now imagine that this is, and then this contour two plots tells you the cloud droplet number concentration. Now this is on the left hand side the cases of Amazon, where if you look into the this particular box, which represents the range of the aerosol particles which I find in Amazon and in the updraft velocity. Now if you look into the contours within this box, you can say that the cloud droplet number concentration is directly proportional to the aerosol. So more aerosol you add, high chances of forming the cloud. More aerosol, more cloud, more precipitation. More aerosol, more cloud, more precipitation. But if I go to the highly polluted Beijing for the same thing, if you look into this box, my cloud droplet number concentration is proportional or is the function of updraft velocity, not of the aerosol. You have already enough aerosol and then it is waiting for the updraft velocity to go up to kind of form the precipitation. If you inject more aerosol, you may even suppress the precipitation. Gone. When I try to bring that for my region, let's say for Munnar, what I do really see is that definitely there are more number of cloud droplet number concentration, even if your aerosol number particle is less, right? So in Munnar as compared to the Gadanki, you have more chances of forming the aerosol cloud droplet as compared to the Gadanki. Now, since we talked about the cloud, right? I think it would probably be a good idea to give you that how these aerosols then form the cloud. Well, why aerosols are important in the cloud formation? That there is a subset of the aerosols which is called as the cloud condensation nuclei, which is nothing but these are the aerosol particles which just go up into the atmosphere, absorb the water, they swell and then grow big enough to form the cloud droplet. That's very simple definition. Now these aerosol particles, whether they absorb the water droplet or they absorb the water and grow big enough to form the cloud so that you can visibly see it, it depends on water vapor supersaturation, meaning that how much water you have in excess of 100% relative humidity, the size of the aerosol particles, and then the composition or the hygroscopicity, meaning that the chemical composition or the hygroscopicity means the ability of that aerosol particle to uptake the water. Now you can simply see it in this context. Let's say suppose if you take a salt in your bowl and then keep it outside, you will see that it automatically starts absorbing the water. But if you take the Teflon ball and keep it outside, there is no way that it will ever absorb water. So that's how the chemistry of that would really change in that context. Now, cloud droplet concept formation, just for the orientation purpose, I would like to tell it to the audience that the homogeneous nucleation of water vapor, meaning that all the water droplet, small water droplet coming in together and then forming the big cloud droplet is impossible in the real atmosphere, because you would then need the relative humidity of 800%. So that is never possible. So only the pure water droplet coming in together and forming the cloud droplet is not possible in the atmosphere. Then what really happens? What is the magic in the atmosphere? Well, then what happens is that this water vapor then condenses on the pre-existing aerosol, which we call it in the the CCS. And then without going into this thing like Kelvin effect, like Rawl term, just try to understand that the Köhler combined these two effects and came up with the Köhler theory, which tries to tell us that the hygroscopic growth as a function of relative humidity, meaning that how the particle grows, and then the CCN activation as a function of supersaturation. I'll not go into the mathematics of this at this moment, but let's try to understand this is the supersaturation ratio, meaning that how much it can hold and then how much it is really holding. And then this is the droplet diameter, meaning that if the droplet has to really go and then become the cloud droplet, so if you have a small particle, you really need an extremely high supersaturation, not possible in the atmosphere. So Kelvin term, it's not going to help in this direction. Then what you do is that you have some sort of an impurity in the atmosphere, which is an aerosol particle, so that water can condense on it easily and then it can grow up. This is called as the Raoult term. When you combine these two, it is called as the Köhler curve. Now, this is a very important aspect. This Köhler curve gives us two important parameters. One is that if you know the diameter, critical dry diameter of the particle, that how much that dry diameter is, it will tell you that how much supersaturation is required for you to form the cloud droplet. Or if you know the supersaturation in the atmosphere, it will tell you that what is the critical dry diameter for that particle to become the cloud droplet. So supersaturation and critical dry diameter are the two important aspects which we will get it from it. These are just an exemplary curve for the ammonium sulfate. That as you see that your diameter decreases, as your diameter is increasing in this direction, that the required supersaturation in this direction is decreasing. So meaning that larger the particle, high the chances of forming the cloud droplet. But at the same time, if the particle is not hygroscopic, then it also requires higher supersaturation. So they, to avoid this entire complication related with the chemistry, in 2007, Peterson and Weiss came up with a very landmark paper. They introduced this single parameter called as kappa, which is a unitless quantity. So what this kappa tells you is the higher the value of kappa, better the ability of that aerosol particle to form the cloud droplet, and then lower the value of kappa, it is a very bad aerosol to form the cloud droplet. So that's what you have to keep it in mind at this moment. Now let's try to take up the case of Kerala, right? You know what probably must be the scenario. Let's try to imagine this now. You have a pristine condition in the atmosphere. Now, in the pristine condition, you have the given this situation. You have the given liquid water content and then very small aerosol number particles. Now, with this number of aerosol particles, the cloud droplets are forming. The cloud is forming. Since the number of aerosols are optimal, even before this cloud crosses the sub-zero temperature, the precipitation is the cloud is formed, and then the precipitation is occurring, and then obviously the next cloud is really formed, and then the cycle goes on like this. Now imagine this scenario: you have similar amount of liquid water content, but your aerosol concentration is very high now. Now what happens when this cloud is forming? The cloud droplet number concentration is very high, but their size is very small. Now, because of the smaller size, their collision and coalescence efficiency is very low, meaning that they are not really kind of growing big enough by coagulation and coalescence. Then what happens is that since the precipitation is not occurring, this cloud will cross the sub-zero temperature, and then the ice crystals will start forming. Now, once the ice crystals start forming, it will release that latent rate of freezing. And what it then basically does is that it puts in more of energy into the cloud, and then it goes further up into the atmosphere, and then it can just come as a very strong cloud burst. So what aerosol they do, they may delay but enhance the precipitation. And then most likely in majority of the cases, this is really happening. But this duration is up to 3 to 4 hours, maybe, I don't know, but without bioaerosols. I'll come back to the bioaerosols, what they do. More aerosols, delayed but enhanced precipitation. Paisal, do I still have another 15 minutes?
Yes, sir. Yes, sir. You can do. Yeah. Yes, sir. Yes, sir.
Yeah. Okay. So I will now then present the very typical scenarios what we have basically studied so far. Let's try to take this case of New Delhi, right? You know, how do the aerosols then do affect the local scale? Everybody was talking about this Delhi, like, you know, there is a smog, and then this visibility goes down, and then the air traffic is really disturbed, and so on and so forth. Let's try to see what happens now. So if you look into these 30 locations across the globe where the chemical composition is measured, you would see that it is primarily dominated by organics. Then you have sulfate, then you have ammonium, and then you have nitrate. But when we did the measurements in Delhi, for example, what we found is that in Delhi, it is exceptionally the chloride was high, which was never observed anywhere in the world. The 10% of the total mass which was observed was chloride, right? Which was never observed in the world. And then we were wondering that where does this chloride come from? Now this is how we basically went on to investigate that what was there. So we did the measurements in Delhi in 2018, and what we found is that we put an hypothesis saying that this particular chloride is coming because of the plastic burning. But we did not have any fundamental proof or a scientific proof to do that. Now what we did, since we have only one instrument, we came back to Chennai in 2019 and did the measurements during the Bhogi festival. Now what we found very interestingly that during entire month except Bhogi period, the Chennai behaved as if like any other global site. But only on the day of Bhogi, we found an extremely high chloride concentration. Now let's try to understand that where does this chloride concentration come from? When you burn the plastic, and then the metal pickling industry in Delhi, they release that hydrochloric acid, and then you have the livestock and fertilizer use, like mostly the agricultural use, they will have this ammonia, and then of course in the ammonium NHX you can call it, and then you obviously have an ammonium chloride aerosol form. So ammonium will first try to neutralize sulfate, nitrate, and then it still is there that it will then try to utilize the chloride, and then even after neutralization we found an extremely high chloride concentration here. Now if you go to just Google it, and then as an auspicious and righteous thing, as a mark of new beginning, we try to burn the old things. Sometimes it may just contain some of the things which should not be there as far as the burning is concerned. So that's the reason this ammonium chloride comes in, and then ammonium chloride has the very high ability to absorb the water. If you go to New Delhi area, for example, all these dumping sites will always be on the fire, because what they do is that when you have these dumping sites, to kind of put in more dump on that, they will spray the water, and then because of that water, the composting happens, and then because of this composting, you have a methane gas coming in, and then it is slightly flammable. So every time you will see that any dumping site will be smoldering, and if any plastic comes into the contact of that burning, then it's really a very dangerous one. Now, how did we solve this mystery of the daily air pollution? Now, this is a very simple graph. You can see that this mass of the PM1 particle, and then this is the mass fraction of different chemical components like chloride, sulfate, nitrate, and organic. What we found in Delhi, that moment you cross 90 microgram per meter cube, the entire increase in the mass concentration of Delhi PM2.5 is caused by the chloride. Right? So the chloride is extremely important. Now, what does that chloride do? The problem with the chloride is that it is extremely hygroscopic, meaning that the ability of that chloride particle to absorb the water is much higher than any other compound. Now, if you see that a very slight increase, this is the relative humidity, and this is the mass concentration of different organic, sulfate, nitrate, ammonium, and chloride, and also water. You can see that a very small increase can cause an extreme exponential increase into the water content of an aerosol. Now, once this water content is there, then the particles are so big that they can obviously reduce the visibility and cause the fog formation. Let's try to understand a little bit more about the Chennai region, that how this totally different than in Delhi. We have all seen that during the lockdown period, everybody saw that, like, during the lockdown, the air was clean. During the lockdown, air was clean. Yes, of course, it was clean. But we found a very interesting information in Chennai when we did this campaign. You can see that this is the satellite looking down, that how many souls are there. You can see that for April and May, you see that there is a lot of, like, this is the unitless quantity of AOD, which tells you that higher the number, higher the aerosol concentration. Yes, it was relatively clean. Now, when we did the measurement in Chennai, like during the lockdown period, this is the time, and this is the mass concentration of different type of aerosols, like PM1, PM2.5, whatever it may be. Now, what we found that during the lockdown, consistently the particle concentration remained low. But there was one particular day where we found that particle concentration reached as high as like 40 microgram per meter cube, which we really didn't expect that why that should happen. When we tried to look into the physics of this, what we found is that as the time progressed, this is the diameter, which is color scaled by the concentration. What we found is that as the time progressed, not only that your particle concentration increased, but your diameter also started increasing, which is generally called as the new particle formation, as a banana shape, which they call it in the community, is an indication of the new particle formation. So what we realized is that some new particle formation was going on. When we looked into the chemistry of this, we found another interesting aspect, that when this event was going on, right from 8 o'clock in the morning till 8 o'clock in the evening, we found that it was mainly dominated by the sulfate. Now, under the reduced anthropogenic activity, it is very unlikely that the anthropogenic sulfate was coming in. When we looked into the chemistry of this, what we found is that, of course, the phytoplankton activity that releases the DMS, that's dimethyl sulfide, which can then go on to oxidize and then gives you the sulfate aerosol. So what it basically tells us is that under the natural conditions, how the clouds used to form, right, at the marine location. Generally, this kind of an event is not observed in Chennai, because when you have the pre-existing aerosol, very high aerosol concentration, whatever the gas which is responsible for the sulfate aerosol formation will condense on this pre-existing particle and will suppress this kind of particle formation. Now, the most important part in this, please recall that this sulfate aerosol, they have an extremely high kappa value, meaning that their aerosol, their cloud forming property is extremely high. But if the sulfate aerosols are not there, maybe you are kind of compromising that how the clouds are basically formed in Chennai. I'll simply skip this bit just for the sake of time, but we'll move on to the bioaerosols. I'll try to wrap up in another 7 minutes or so now. What happens with the bioaerosol is that they are important in two ways. Not only that they are important for the climate, but they are also important for the ecosystem here. Now let's try to understand this. We say that the ice crystal formation, right? For any cloud which goes above the sub-zero temperature, the ice crystal is formed. Now, if you have the homogeneous freezing of the water, it takes minus 80 degrees centigrade, meaning that cloud has to really go far up into the atmosphere. But if you say that if there is any non-bioaerosol heterogeneous ice nuclear formation, that can still happen at minus 30, but it still has to go above sub-zero temperature. But if the bioaerosol is present, what has been noticed is that the ice crystals can be formed just at minus 3 to minus 10 degrees centigrade, meaning that cloud doesn't really have to go far up into the atmosphere, right? Now, what is happening is you are actually advancing your precipitation. If I look into this one, this is the temperature on the x-axis, and this is the potential ice nuclei, the concentration of the ice nuclei. You can call it as the potential of the ice nuclei, for example, right? Now, if I look into this for the non-bioaerosol, you can see that it really starts and goes up to minus 35 degrees centigrade. But if you look into the bioaerosol, it can start really at minus 1, and then by minus 10, you have really very high concentration of the ice crystal. But not only that, but they have the very peculiar ability to kind of affect the plants and then the human health. Like, recently this 2010 classic Nature paper had shown that there is an increase in the plant infecting fungi, right? So there are specific type of fungi which they basically affect the plant, and then we just use this typical fungicide. But please understand that the fungal spores, unlike the bacteria or viruses, they have this incredible ability that they can survive without the host, meaning that if there is a pathogenic fungi here, it can still travel like 2,000 kilometers and then affect a plant there, because it just doesn't require any host to survive. So if we do not pay attention to better understand the type and diversity of these fungi, maybe 25 years down the line, we will be talking about the plant pandemic rather than the human pandemic. These were the typical results from Munnar, but I would skip it for saving the time, would not go into the details. These are the measurements from Chennai. So what this basically says is that this tells you the species level distribution of the bioaerosols of bacteria, and this is for the fungi. You can see that most of them are bacilli, then the gamma protobacteria, and then they are dominated by actinobacteria, so on and so forth. And then if you look into the fungi, for example, that majority of them are ascomycota, then followed by the basidiomycota and zygomycota. Why these things are important? Obviously, because as far as the impact on the climate and then the human health is concerned, these type of species level diversity is important for us to understand. This is again not going into the details, but what it shows is that if you go by the time series and look into the different parameters of the biological aerosol, we see that there is a typical diagonal variation, there is a specific type, then they are high. So we are trying to, I have a student, Emil, she is working on it now to understand why these kind of typical variations are there. Now, just to give you a very good idea about this ice nuclear formation, now this is the water which is at minus 7 degrees centigrade. And then if you look into this, the moment you kind of put the Pseudomonas syringae bacteria, that the water freezes, right? Whereas if you want to freeze this water by putting any other object in that, you would really need a very lower temperature. And then this is really represented depending upon the type of the bacteria, the temperature which it requires to form the ice crystal is totally different. Then we also did some studies looking into what type of a specific fungal spores are affecting which kind of a plant in which region. This is just as an thing of that, and this is the. Oops, it's just not changing now. Yeah, if you look into this, no, what is happening? Yeah, I'm not going into the details of that, but then the idea is to really show you that it is very complicated. So if you want to know that what kind of a bacteria or fungal spores are affecting which kind of plant, this is just one example. My student Emil and a postdoc Sharayu, they have done some measurement in Gurda school to understand how the bioaerosols affect the Rabi crop, right? And you see the complications in that, right? I have no intention to really explain you at this moment that what this basically the graph means. I just wanted to show you that how complicated the type and diversity of the bioaerosols can be. If anybody wants to know, please get in touch with Emil and Sharayu about it, right? All right, I think I'll also skip this part of it with the health and just try to conclude with this, with the challenges and future scope. Well, I mean, of course, what we do really know is that the properties relevant to the climate are the physical and biological properties which have a seasonal variation. And then over the Indian region, there is the role of distinct environments. And then through the air pollution, obviously, it affects the climate, the visibility reduction, smog, haze, extreme climate events, ecosystem health impact, right? And then the secondary aerosol formation. We need the improved understanding for this. The field campaigns are extremely necessary. And then, of course, the high altitude laboratory in Munnar in collaboration with ICCS is really helping us in this direction. So I have written that in the green color because we do have a fairly some sort of an understanding about what is basically happening there. When it comes to the health effect, right, the stress due to the various radicals, like the oxidative stress on the cells, then it is the response to the toxicity, how it affects. I have a PhD student, Rizana, who would be working on this, and then of course most important is the immunological response to differences in the individual, how it affects. And then the air pollution, of course, affects it because we then need to understand the radical chemistry of the PM2.5, how the secondary aerosol formation is happening, how dangerous they are, and then the multiple aerosol processes and surface chemistry, right? And that is more important for the life and health because the radical chemistry, I'm putting it in slightly red color, we don't know. Toxicity, we have no information about, and then the immune stress response, that how it is going to affect the human health in future. Yeah, with this, I would like to thank for this opportunity and would be happy to take questions if any. Thank you, Paisan.
Thank you, Professor Sachin. It was a fantastic lecture. Actually, you started from very fundamental, different types of aerosols and how their sources, and even chemical properties, and ultimately reaching to challenges and future scope also, and how that actually impact climate change related aspect also. So we also have got a few questions. So you might have seen that in the box also.
Chat box.
Chat box. So we will take that. Are you seeing that? So you can.
Yeah, that. So the question is like aerosol effect is depend upon the local area, and burning of waste material is the main source of increase the aerosol particle. Yes, that is what we have seen in Delhi because as I said that depending upon these properties and characteristics of the aerosols, they do have definitely the local implications as I have shown in Delhi. Like if you look into all our papers, this Raj et al and other things they do have. And then, but of course, like as the transformation and aging happens, of course, their chemical and physical properties would change, and then can have an impact on the regional as well as on the global scale. How does the size of CCN vary over the coastal region? Well, I mean, if you look into the size distribution of the aerosol, irrespective of which area you are measuring, right, from the Arctic to Antarctic or Pacific to Atlantic, around like 80% of your particles would range between 20 to 200 nanometers. That's the reason the most important size range for the cloud formation. That's what we basically look into. Now within that size range, let's say for example from 20 to 300 nanometer, where you are measuring the peak, the total concentration, the broadness, the narrowness of the size distribution would look into. Now coming back to your question, in our coastal region, I think in Chennai we do get the peak at around 110 nanometers. I guess I have to look into that, but around 110 nanometers is the one where we get the peak. There's the vertical distribution of aerosol affect. It does definitely affect the cloud formation.
Okay, nice. Actually, now some few questions from my side. Actually, you had said that aerosols number actually impact the cloud formation. You have got less number, and then it grows faster. At the same time, when you have got more number CCN, they actually compete for the moisture and delays the precipitation process. But then they give you extreme rainfall. So how actually that extreme rainfall? I think that may be interesting to know. Maybe able to explain many of the extreme process in at least some parts of the country.
Right. So what happens, sir? I have not shown the measurements here in detail. We have done a lot of cloud condensation nuclear measurements, right? Because the CCN the problem with the CCL measurements is that they are very tricky, right? It's unfortunately it is not a plug and play instrument. You cannot simply plug that instrument and then say that aha, like this eureka moment out of this, right? Now what happens is that sometimes you need to have a very accurate data to draw the interpretation out of this. So particularly looking into this fact that, like, as I said, when the more aerosols are there, it crosses the sub-zero, the latent head is reduced and then it's released, and then it kind of invigorates the convection and then the precipitation happens. Now, simply by saying that, like, this theory was proposed and then you haphazardly measure some droplet number size and this and that and everything goes into that, unfortunately it is not that easy. So when we did some campaign in Munnar this year, we did find some very interesting events where we could see that, like, in Munnar we don't expect any natural, any anthropogenic source during monsoon, and then it was also locked down in between. Now what we saw is that when you have a very strong peak into the aerosol concentration, being the vegetated area, you see a very high concentration of the natural aerosol. Now the natural aerosols, the way they affect the cloud form from the anthropogenic aerosols, right? So that also we need to understand before kind of reaching to this particular conclusion. So yes, in Munnar, I think we will collaborate more with ICCS to look into this aspect that how this extreme precipitation is happening.
See, and another aspect is this is that we know impact of greenhouse gases on the global warming and aerosols, many things. But at the same time, in the particularly country like India, where we have seen that in spite of global warming is taking place, the precipitation is decreasing last few decades. So what could be impact of aerosols? Is really anything? And at the same time, the future climate impacts are suggesting that actually precipitation is going to increase. So how, and again, do we expect some changes in the aerosols part also?
Well, I'm not really sure, or what my understanding or belief is that if you look into the overall seasonal rainfall over India, that has not decreased. It has remained constant under the climate change scenario. But what has probably changed is that there is an increase in the intensity and frequency of the extreme events. So maybe the temporal distribution has changed. So if you have an X amount of rainfall which is expected during the monsoon, so that X was probably divided very fairly enough during the monsoon, but now that has changed. So I do not really know if the rainfall has changed. But what we do expect is that because of the warming, you have more water vapor, like in the vapor form, and then how do these aerosols would interact with it? That is going to be the real challenge, right? So indeed, what we do expect is that it will really increase the intensity and frequency of extreme events. But how precisely these roles of aerosols is going to play an important factor. Like, what we find is that maybe that suppressed on the western side of the Western Ghats during monsoon because of the high aerosol, it may just kind of cause an increase in the precipitation on the eastern side of the Western Ghats. And that's what if you look into all the mudslides which has happened over the last few years, they are basically happening more towards the eastern side of the Western Ghats. Now, to draw that such a strong conclusion, I would probably need a couple of more measurements and modern studies that how and what it is. But right now, what I can assure you is that we have pretty good data from the measurements in Munnar, which we did it this year.
Okay.
There is one question I may take. Can you please describe more about the Kappa and Euler curve? Well, I mean, you could really refer to the Creden-Weiss paper or any of our papers. If not, then please write to me and then I can really explain you in detail there, no problem. But I think just for the sake of saving the time for all the audiences, we would stick to that. But just please do not hesitate to get back to me if you need more information about it.
Yeah, that is correct. Actually, Divya can actually contact Professor Sachin and actually, get more on that. In fact, anybody in this, that, and Sachin always accessible to anybody. So you can actually contact him, write him email, okay, and get it, or you can contact him. Any other question? Sir, I think another question, wind is playing role to carry the aerosol distribution.
Wind is playing the role to carry this aerosol. Yes, of course, it does play a role. I mean, even at even in Chennai also, we sometimes see that if the wind is stagnant, your aerosol concentration and chemistry is totally different than if the wind is faster, right? Now we are having a very interesting paper coming up soon in a very high impact journal about particularly the impact of wind on aerosol chemistry and physics and then the cloud formation in Chennai, right? Just stay tuned for that paper. I would definitely send you that.
Okay. I think, now there is no more, I think questions are
Sir,
there. So
I have a question. May I?
Yeah, Sinan, Sinan, you can.
Yes. So it was a really nice lecture, and in you have mentioned that the bioaerosols play a crucial role in deciding whether the clouds will go sub-zero or not. So I was wondering, during the measurements in Munnar, does particularly Kerala has that severe impact by bioaerosols?
Yeah, I mean, it does. We have a very nice papers published in ACP, and there is another one which is now coming in Nature Communication about the bioaerosol in Munnar particularly. See, the bioaerosol is everywhere, right? So depending upon the land use and then the human activities, their composition and the basic properties are different. In fact, in Munnar, we do find more of the fungal spores than in Chennai, because Chennai we see more bacteria, right? Now, because of course you have more human activities in there. Being the vegetated area in Munnar, the fungal spores which are there, like how their composition and how they really affect the cloud, that would probably need for us to understand, more time to understand that how it goes in. But indeed, yes, in Kerala we do see, of course, the bioaerosols, they are everywhere, right? Now, maybe slightly more in Munnar as compared to Trivandrum, but more or less it remains. So if you look into the total aerosol mass burden, depending upon the environment and season, it may vary from like 15% to 80%. Like in Amazon, 80% are bioaerosols, right? So they are everywhere. Yeah.
Okay.
Sinan, did that answer your question?
Yeah, thank you, sir. Thank you.
Okay.
Sir, actually, I have one question.
So, yeah, Nimisha.
Sir, Kerala has witnessed consecutive extreme rainfall events in recent times, mainly in case of 2018 flood event. So, did aerosol play a crucial role in these events?
Well, I think I do believe that it's crucial role, right? I think I'm hearing my own. Maybe Nimisha, you want to mute yourself?
Nimisha, you can put our sound. Yeah.
So, well, I mean, indeed, we do believe, because see, at the end of the day, that the cloud microphysics is governed by the aerosols, right? You have macrophysics like, the dynamics, which is responsible for bringing the moisture onto the continent. That's totally a different subject with the monsoon dynamics, like how the moisture is transported and then if there are disturbances and then the moisture is coming or not, right? But come what may, that the precipitation is microphysics, period, right? It is microphysics. So whether the precipitation is enhanced or delayed or less or more, that is really governed by the microphysics, that is the interaction with the aerosols, right? Now what we do know is that definitely aerosols have had something to do with those extreme events, right? But how and what scale or what composition or what the processes was, that's something which is not clear to us. But I think I would probably say with a certain degree of confidence at this moment that indeed I believe that the aerosols would have played a very strong role in the extreme precipitation. Because the amount of moisture, it didn't happen that the amount of moisture as a small pocket came in and then it just went in there, right? No, not possible, period, right? So indeed, aerosol did play. But I think we will soon get that answer now, since we have the measurements from Munnar that what did, because I should really thank Professor Sudhir and government of Kerala for having us that laboratory there, right? Because the good thing with that lab is that the bird fly distance from our lab to the Arabian Sea is hardly 85 kilometers, right? And then what happens is, because of that small strip in Kerala where this high population density is there, during the monsoon season, whatever the emissions are there, they are washed out. So what we get at 1,600 meters as the monsoon progresses is the clean marine influx. So then we do really understand that what type of aerosols are coming from the ocean, right? Their chemical composition, size and everything, right? And then once we know that basis, we can then add into the human aerosols in a specific model and then understand that how the precipitation is affecting that. So we're getting there. We'll get there soon.
Okay. Okay. I think, we are getting time also. So,
Sure.
yeah, it's a fantastic, actually, Professor Sachin. So, before moving to our final stage of thanking, out of thanks, I just personally thank you very much, really. It was a really fantastic lecture, and I'm sure everybody might have enjoyed that. You touched actually very fundamental to very important, which is a topical. Also, and nicely explained its impact on air pollution or climate, how it is impacting. I actually suggest those who want to actually have more questions or one clarification, you can directly write to him and or contact him. So before we end, I give back to Shilpa for a final out of thanks. Shilpa.
Okay, sir. We will now proceed to the final section of this event. I'm delighted to submit a vote of gratitude on behalf of the ICCS to today's Chief Guest, Padma Shri Dr. M.C. Dattan, Scientific Advisor to Kerala's Chief Minister, and Professor K.P. Sudhir, Executive Vice President of KSCSD, who took time out of their hectic schedule to grace the commencement of the ICCS online lecture series. I would also like to express my gratitude to today's keynote speaker, Dr. Sachines Kunthe, Professor IIT Madras, for being so generous with your time and choosing to be live with us to offer this outstanding and thought-provoking speech on aerosols and climate change. I would want to use this occasion to express my gratitude to our director, Dr. D.S. Paisa, for his initiative in organizing this lecture series and for his unwavering support. I would also like to thank my colleagues at ICCS for their support and guidance. My deep sense of appreciation and thanks to all the participants who chose to be live with us and attended the webinar with great enthusiasm and made it a successful event. Once again, I thank you all for sparing your time and being with us. Have a wonderful day ahead. Thank you.
Thank you. So just to say that, Pai sir, if I may
Yes.
take a second.
Yeah. Yes, sir. Yes, sir. Yes, sir. Please.
This is the picture of our lab in Munnar, right? So anybody who wish to go there, please do it. It's very difficult to do the measurements there, sir. Extremely difficult. I'm thankful to the government of Kerala College of Engineering, Munnar ICCS, that my student have stayed there for 4 months and did this measurement. If anybody wish to visit, please let us know. Thank you.
That is good. Great. Great. Thank you, Professor. Actually, okay. So contact with us. Actually, thank you very much. Thank you. Thank you all, Sanjay. Everybody, all my, or everybody, those who have joined.
Thank you,
IMT and all other organization, Ghosh, everybody. Thank you.
Thank you.